I guess we are on time, so let me kick this off. So good evening, everyone, and welcome to the next session of Sitecore User Group Jaipur. And in today's user group meetup, we have two very known faces of the Sitecore community. So I would like to introduce first Jamie Davis, who is 9-time Sitecore MVP and working as a solution architect, and Michael Edwards, who is 9-time Sitecore MVP and working as a technical director. So we'll start first session with Jeremy, and then next session will be Michael. So I'm going to handing over the session to Jeremy. And Jeremy, I think you can start the session.
Let me share my screen. Right, hopefully my slides will be popping up for you all now. But hello, everyone. Thank you so much for joining me for this session. And I will kick off with a little introduction to my topic and to me. A couple of years ago, I was speaking at a few of these events in England about getting started with Docker as a Sitecore developer. And since then, I've got to work on a couple of projects that have deployed containers through to production. So I figured it was time for a bit of a follow-up, as there seems to be more interest in the use of containers for Sitecore deployments these days. For those of you who've not met me before, hello, I'm Jeremy. I work for the solution architecture team at Unrivaled in the UK. We're a platinum partner working with a wide variety of Sitecore clients, and we do a few other content management platforms too. As mentioned, I've been doing mostly Sitecore work for well over a decade now, and I've been lucky enough to be an MVP for nearly as long, largely due to a lot of blogging, which I've linked on the slide here. And somehow I got tagged as the containers person at work. So my plan for this talk is fairly simple. I'm going to start with why this technology might be of interest to you. I'll go over a bit of the big picture behind what infrastructure is involved. I'll explain a bit around the basics of build and release and config and scaling. And I'll wrap up with a brief conclusion, and I'll take any questions you might have at the end. But this is potentially a very big and complicated topic, so I'm deliberately going to keep this talk quite high level. I'll try and summarize things that you need to think about in order to get started. Okay. So it wouldn't surprise me if a few people here are as skeptical about this as Mr. Fry here. You might well be thinking, oh, it's another hyped technology. And if you were like me, you probably just got comfortable with Azure PaaS when all this stuff started to appear. Well, it's important to note that you do not need to change, but maybe you might find some benefits here if your project has the right requirements. But I'll start at the beginning. This is all about containers. So why might we want those? Well, first up is isolation. A bit like virtual machines, stuff in containers gets kept separate from the other things going on your computer. So as a developer, you can get away from trying to juggle 4 different versions of Solr on the same computer for different projects. And code inside your containers can't easily consume resources like memory and CPU that you've not explicitly shared with them. So overall, using containers to get this isolation has less overhead than the old model of using traditional virtual machines. Secondly, containers are immutable. That's kind of a fancy word, meaning that they can't be changed. Once you build the image file to run a container, that same file gets deployed everywhere. So you get consistency across your deployments. And because each new image is built from scratch, it's harder to leave old files in place by accident and make mistakes like that. And thirdly, there's no CIF installs to mess up anymore. And I'm sure we've all suffered a bit of pain at the hands of that. Now, in local development, you get all these things from Docker. So what is Kubernetes actually adding here? Well, the key difference is called orchestration. Docker can run your containers on a single computer, but Kubernetes can spread this out over multiple servers to give you load balancing and resilience. There are other orchestrators, but this one happens to be Sitecore's preference. It can manage the containers for you, deciding how many to run and which physical servers to put them on. It can balance load between those machines based on criteria that you define. It can manage your configuration and secrets for use by containers. And it can aggregate together logs for monitoring. Your physical infrastructure can vary, but that gets abstracted away by the orchestrator here. And one important thing that might vary is potentially your cloud provider. Historically, Sitecore has been pretty focused on Azure for deployment, but in theory, you can get the benefits of containers on any platform that can run Kubernetes for you. It's probably easiest to deploy on Azure, but Google and Amazon's clouds both have Kubernetes services. And if you wanted to, you could run this on your own infrastructure as well. But for me, I think one of the key benefits that I've found with this has been simpler upgrades. Because you build deployments on top of Sitecore's images, you get to get rid of a lot of tedious manual steps in these processes. You're probably going through a process where you're updating NuGet references and Docker files to match the new versions, and that might lead to you fixing some breaking changes in code or config if necessary. But then you can build a new release, and maybe you have to tweak a few environment-related things if Sitecore made changes there. But then you can redeploy, and potentially you get to run some kind of update jobs in your containers as well. But fundamentally, you're not worrying about those nasty 90-page upgrade PDFs with all the instructions about what DLLs to copy and what line-by-line config edits to suffer through. So potentially this approach can be much simpler than the older models. So if this stuff does pique your interests, what do you need to consider in terms of infrastructure? Well, you'll probably be pleased to hear that broadly Sitecore doesn't really change here. We're still talking about SQL and Solr and firewalls and things, but now with Kubernetes at the center. Whatever cloud provider you pick here, you're basically buying virtual machines to run Kubernetes for you. They execute the Kubernetes code and they run your containers, and they're usually referred to as nodes in the system. And because containers come in Windows and Linux flavors, so do nodes. That's because a container runs best on top of its own operating system. As a minimum, you're going to need one Linux node for Kubernetes itself and for any Linux containers you might have. And Sitecore needs at least one Windows node. But in reality, you're going to need multiples of both types. And you get to decide on what sizes and scales and so on you use there. But I will talk a little bit about scaling later on. You also need a private container registry. When you build images for your website, you have to store them somewhere, and a registry does that for you. Your build process pushes new images to it, and when you release, Kubernetes pulls from it. So you need to set up the right security in your cloud infrastructure to enable that flow. Unsurprisingly, you're going to need some databases. For development, Sitecore have a container image for SQL Server, but this is not for use in production. They don't provide proper support for it, and it's not scalable, so you're not going to want to use that. If you're deploying to Azure, it is probably simplest to use the same SQL Elastic pools that you would use for PaaS deployment. Outside Azure, well, all the other cloud providers have their own SQL Server products, and Microsoft also has SQL Server images for both Windows and Linux containers if you want to go down the road of managing this stuff yourself. Now, when you scale out content delivery servers for Sitecore, you need some sort of external session state store, particularly if you're running XP. And while that can be a database provider, Sitecore promote Redis for this. And that runs happily as a PaaS resource or as a containerized instance if you want to go down that route. And it's generally fairly easy to acquire that. But Sitecore's internal search is one place where Azure doesn't do quite so well, particularly now that Azure Search is no longer an option. So SaaS is a common option for this. Products like Search Stacks can provide the infrastructure and support for you, and that works fine with containers. Or you can manage your own VMs if you want to go down that road. But Kubernetes is actually pretty good at running Solar Cloud. Like SQL, Sitecore have a developer image for this, but it doesn't scale for production again. So I am a fan of a tool called Solar Operator. It's maintained by the people who build Solar and Zookeeper, and it gives you scripts to automate deploying Solar Cloud clusters. You tell it how you want the system to scale, and it generates the right deployment config files for you. I wrote a blog post about a basic demo example of this a while ago, which I've stuck a QR code here for if anyone wants to go and check that out. I said earlier, Kubernetes can gather up your container logs for you. Basically, a bit like Docker, it's taking anything that's written to the standard out stream for your containers and centralizes it for you. Fairly commonly under Azure, people route that to log analytics and app insights kind of resources as the most common approach. But again, if you're more focused on running things yourselves and you prefer the host it in a container approach, there are tools like Prometheus that will give you similar behavior, but with resources that you control rather than your cloud provider. And you can, if you want to, stick to traditional log files here. Containers do still generate them, but there is a bit of work you have to do if you want to store them. And I will come back to this point a bit later on. A couple of other things that are worth thinking about here. Firstly, these days we're much more commonly building headless sites, and they are going to need some sort of hosting for the rendering host role. So you might be also running containers for Node.js or .NET Core to host that potentially, but you are free to choose external SaaS services like Vercel or cloud-based hosting tools like PaaS app services here instead. Those will also both work fine if you're deploying Sitecore and containers. Secondly, you do in the background need to consider all your infrastructure security stuff here. It's fairly obvious, I hope, but you're going to want some sort of firewall that's going to protect your site and your resources. And you're going to need to manage your internal routing for access to the resources you deploy that are outside of Kubernetes. All the cloud providers have their own approaches to this and their technologies that support it, but frankly, that thing is a whole presentation in itself. And kind of lastly for this bit, I wanted to point out that if you're interested in a basic worked example of a Kubernetes instance in Azure, Sitecore's Bart Plasmaier, I think that's how you pronounce his name, I'm never quite sure, wrote a GitHub repository a while ago for a conference, which has a bunch of PowerShell scripts that will go through the process of setting this up for you. And I have to say that reading through that and having a play with it helped my understanding quite a lot. So it's worth taking a look at that. But once you've got to a point where you've got your initial infrastructure in place, you're going to want to think about building and deploying code to it. And big picture, this broadly works kind of like Docker. You are building your images, you're giving configuration files to your orchestrator, so it can run your containers and tell it what you want it to achieve with its resources. And much like the Docker stuff, Sitecore provides some example config files that you can use for Kubernetes. They live in the zip file that you get your Docker config from on Sitecore's download page, but they're not really structured in the same way. Broadly, you still get the XP1 and XM1 versions, so scale deployments, but with and without analytics, depending on what's appropriate for your project. But where Docker uses 1 or 2 files to run a local instance, this gets broken down into a lot more files. You get one for each of the Sitecore roles you're deploying. You get files for the ingress controller, which I think it's worth mentioning is Nginx here, not traffic, because that's more appropriate to production scenarios. You get optional files for Redis and the Solr and SQL kind of non-prod containers that I mentioned before. And you get files to help you set up all of the environment values, so the Kubernetes secret store can hold them. Though another point it's worth making there is that quite commonly these get integrated with something like Azure Key Vault to give you kind of centralized storage. And you get files for Sitecore's initialization jobs that help you set up SQL and Solr for a fresh deployment. And as I alluded to a bit earlier, recent versions also can come with config for upgrade jobs that you can use for moving, upgrading analytics databases and things when you move between versions. But together, all those files can deploy kind of vanilla Sitecore, but you will end up customizing them. And probably the most important bit of customization to release your site is that you're going to want to use custom images rather than Sitecore's basic ones. For that, you're going to need a build process, and your pipeline starts basically with the standard kind of source code build for your site. Now, if you've done any work with Docker, you'll be aware that Sitecore provide things called Docker files, which are instructions that can tell Docker how to build up a custom image. And there's an important point here that this for security reasons, when you're telling Docker to build those images, the engine that does this can't go back up your directory tree and your solution to find files elsewhere. So the build process that you set up for this has to copy all the relevant outputs to folders that live under your Docker files so that they can get put into your images. And you're likely doing this for content management and content delivery roles, maybe for Xconnect or for rendering hosts if they're appropriate to you. And once you've set that up and your code build has run, you can then run the Docker build process to take those Docker files, layer your files on top of Sitecore's images, and then the Docker push command can send these new images to your registry. It's important to remember that you need to tag these images with proper kind of build version numbers so you can release specific versions. Don't rely on just the latest tag for your deployments. That will lead to pain. And once you have config and images set up, you can do a release. There is a command line tool for Kubernetes, which is called kubectl, that you can use as part of your release process. And one of its key features is that it can send config files to your cluster. For an initial deployment, you get to send all the config that we talked about earlier, pretty much, in order to get the sort of basic state of the site set up. But your follow-up deployments only need to send the changes. And most of the time, that's just going to be telling it which image tags it should download and run. But an important point to note here is that the process of kubectl's config change is asynchronous. Sending the config files will complete quite quickly, but the process of actually changing over to these new images and running your code can take longer. So when you set up your release process, you need to explicitly wait for that change to complete. And again, kubectl has some commands that you can make use of in your pipelines to do that. But once that process of switching over to new images is completed, you can then trigger whatever post-deploy steps your project has in the normal way. Maybe synchronizing serialized items or warming caches or stuff like that. There are some other aspects of config for production, though, that I think are important to mention here. First up, while I mentioned before that images can't change at runtime, you can still write to disk in a container. But those writes get lost when your container gets unloaded from memory. Your orchestrator might unload containers surprisingly often. Certainly when new releases happen, maybe when it's balancing load between nodes or it's handling an error condition, perhaps. So a bit like Docker, we have to solve this problem with something called volume maps. They map folders inside your containers to some sort of persistent storage that sits outside of Kubernetes. And that allows your files to survive when a container is unloaded. But you likely do not want to map this literally to disks on the virtual machines for your nodes, because containers can move between nodes, and in that scenario, you still lose access to files potentially. So you need to deploy the right storage resources in your cloud infrastructure. And this is another place where Sitecore provides some example config for mapping volumes to that storage. They give you some files for examples for device detection, for XConnect submit queues, and for the server logs scenario I mentioned earlier. But there might be other things in your solution you want to persist. For some people, that might be Solr and Zookeeper data, for example. And then the second thing that's fairly important here is the broad concept of scaling. By default, containers can chew up as much RAM and CPU as they want and as they can get from your nodes. But you probably don't want that scenario. It's not going to be good on the production side. So you can add config to your Kubernetes config files that allocate resources to individual roles. And you can say what the base resource is, and you can say what they're allowed to do to vary under load. RAM here is fairly easy to wrap your head around. You're basically just setting limits in terms of megabytes or gigabytes that an individual container can get access to. The CPU is a bit less obvious. You specify this in fractions of a CPU core, which is often written in as millicores in documentation. And they use this description because Kubernetes is abstracting your hardware. it's dealing with a kind of a pool of virtualized CPUs, not the physical processors of your nodes. And a bit like SQL pools, you often overcommit CPU because you can be reasonably confident that not everything's going to be busy at the same time in your Sitecore deployment. You can start this scaling process from measuring what your cluster does when it doesn't have constraints. Tools like kubectl can show you resource usage, and they can show you how it changes as load is applied to your site. And you can use that sort of information along with Sitecore's kind of traditional scaling documentation to plan what infrastructure you think you're going to need as your base resources, and what sort of load-based burst limits you might need to set for your site when it gets busier. Like PaaS, you can also set rules about how many instances of a role there can be and when it should scale out. You can set minimum and maximum counts, and you can specify what resource usages will trigger that scaling process. But those resources have to come from your nodes. So whatever decisions you make about scaling for individual containers ends up driving what scale you need for your nodes. And since, as I mentioned earlier, you're running both Linux and Windows nodes, you need to kind of sum up the RAM and CPU resources for your containers of each of those types, and then think about what nodes you're going to provision based on that. And there are a few things worth thinking about here. Firstly, most of the cloud versions of Kubernetes can do auto scaling of nodes, but that process of scaling out to a new node can be a bit slow. So you need to think about how you might trigger that before resources actually run out. You can control the config about what level of node resource usage will trigger the scaling process. And you can also think about this in terms of the scale of the virtual machines. Larger node servers will generally mean fewer scaling delays, but you tend to spend more money running them because you leave extra headroom unused some of the time. So there's a collection of interesting trade-offs to think about here. And secondly, Kubernetes will try and start new containers and get them stable before it goes through the process of disposing of old ones. So deployments require some resource headroom. Too little CPU and RAM at release time can make things slow down. So you do have another choice to make here between paying for the extra headroom all the time, or scaling nodes around deployments, or handling that potential for things slowing down. But there are a huge number of other details that I could talk about here, but that is the broad high level of an initial release. So that's where I'm going to stop for today, at the kind of the 10,000-foot view of this stuff. If you are considering taking these things further, I would strongly recommend Manning Publishing's book, Kubernetes for Developers. I've stuck a link for that here. I found reading that very helpful. But I will end with 4 kind of quick takeaways. You don't need to change, is the first point, as I said at the beginning. Sitecore PaaS is not disappearing right now. And whilst Sitecore made a little bit of noise about containers being the new hotness a while ago, they have kind of rolled back on that a bit, and they're continuing to accept the concept of Azure PaaS deployments. And you can use containers in development without using them for production. That kind of mix and match process is absolutely fine. Secondly, as I've kind of alluded to here, Kubernetes gives you a lot of flexibility. There's a lot more detail to play with compared to most PaaS deployment systems. you have that control over subtleties of config and scaling. Maybe that's important for your work. And as I commented on earlier, I found that doing upgrades in containers is way less hassle for than IaaS and PaaS ones, which is potentially quite important for clients. But as a final point, do not underestimate the learning required to get comfortable with this stuff. Kubernetes is a complicated beast, fundamentally because of that detailed control you can take over things. But with all that said, if anyone's got any questions, I'm happy to try and give you some answers if I can. And I'm happy to chat in other settings too. I've stuck a few contact details on here if anyone wants to. But over to you guys if you've got anything you want to talk about.
Hi, Jamie. There are a few questions in the chat.
Oh, right. Okay. Hang on. Let me find the right window. Right. So Sitecore also has a CLI. So do we need the Kubernetes calls too? Yes, you do, because they're doing two fundamentally different things. The Sitecore CLI will do useful stuff like handling serialization and rebuilding search indexes and stuff like that. But it, at the moment, doesn't know anything about where you're hosting your deployment. It just knows there's an instance of Sitecore to talk to. So things like kube control and the Docker command line and things like that, each one of them has their own little domain of expertise, and you need the right tools in the right places. I mean, Sitecore's command line is extendable, so potentially someone could write a plugin for it that did some of these other jobs, but I don't think anything like that exists at the moment. Oh, Mike has asked about how hard is it to do blue-green deployment and rollback. Right. Well, I guess that kind of breaks into two different bits. There's the code and there's the data. Code rollback and multiple instances is actually reasonably easy, I think, with Kubernetes stuff. There are clever things you can do to give, I think, what people describe as canary deployment, where you can push out a certain percentage of your code as new versions and let it change over time. I mentioned the idea that you've got you put explicit version numbers on things. So when if you do a deployment of version 5 and you realize, having released it, that you're not happy with it, you can do a deployment of version 4 and Kubernetes will take the code back to that previous version. So the code's not too tricky. Like all Sitecore blue-green deployments, the tricky bit is usually the data and the schema. But I think the same tricks that we've used for blue-green deployment in PaaS work there. You can have multiple copies of databases. You can have you can do clever things with packaging to change schemas back if you need to. I think a lot of that approach is still valid, because fundamentally Sitecore didn't change here. Just the hosting technology changed. So your old tricks are still appropriate. Is it possible XM Cloud might be using Kubernetes? I'm pretty sure XM Cloud is using Kubernetes, yes. And similarly, but not the same implementation, Sitecore's demo portal is also using these sorts of things under the surface. I guess you can kind of hold them up as an interesting example of how this technology can work at scale. That if Sitecore have picked it for how they want to roll out, 200 demo sites or to run their cloud services, they've put a fair amount of trust in this technology there. And then, do we have a cost saving, or is it expensive moving to Kubernetes? Oh, now that's a fun one. So I will caveat this with saying that my role is broadly not focused on the cost of these things. There are other people who worry about pricing resources, and I don't spend a lot of time worrying about that. But I think my experience has been that it is not necessarily cheaper. Some of that with the clients I've worked with has been, I think, because we've not got to the point of complete confidence with everything where things are scaled down to the minimum you actually need to run their site. We're keeping a certain amount of headroom for safety and for those I didn't realize it worked like that moments that still pop up every so often because this is complex technology. But I don't think I can point to a thing that says, yes, this is cheaper and here's how much you'll save. It's going to be a bit horses for courses between different projects, I think, because everybody has different requirements. But don't leap on it thinking there's going to be a massive cost saving, I think. Anything else anyone wants to throw out there?
I guess we don't have much questions.
No, that's cool.
Okay.
That either means I covered all the important bits or that the audience is asleep quietly in the background. I'll leave you to judge which. But thank you very much, everyone. I hope you found that useful.
Thanks, Jeremy. It was a great session and very helpful. And also, Jeremy is a active community member, and you can ask questions on Slack and Stack Exchange, and follow his blog as well. Thanks again. And now we can move on to the next session with Mike. Mike, I guess you can start the session.
Thanks, Emmett. Thank you, Jeremy, for that presentation. I haven't had a chance to play with Kubernetes yet, so it's very interesting to me. I'm going to go the other way. I'm going to talk about rendering technologies. Obviously, we are now moving into the age of composable and headless renderings, and there's a lot of different terminology and technology and ways to go in this environment. So I thought I would do a talk on the different tools that you're likely to come across, different terms you're going to come across, and what does it mean if you're moving away from your typical AS.NET C# rendering. So why should you listen to me? So I'm 9 times MVP. I'm currently technical director at Convos. I've been working with Sitecore for, I think, about 17 years, and I've been working in the front end headless space for about the last 4 years. So that's mostly React, Next.js, and some other technologies that we'll see are coming in now. I've also worked on tools like team development for Sitecore and the Razzle products. So quite a few different things that you've probably all used within your time as a Sitecore developer. Cool. So I'm going to talk now about how did we get to this point of rendering technologies where we all want to talk about headless and front-end tools and things like React and client-side rendering and things like that. So I think it's always good just to reflect on where we've been. So we came back from back in the day when we all started with web forms. Anybody who worked with the web forms environment probably knows the pain we had with the page lifecycle, different events firing off, trying to understand when I should interrupt the event lifecycle to do my thing, especially if you were trying to do 2 things on the page at the same time, could be an absolute nightmare. Luckily, we then came to having AS.NET MVC, which simplified a lot of this. It got rid of a lot of the request lifecycle that we just really weren't using. Web Forms was trying to make a Windows desktop experience in your browser, and AS.NET MVC said, no, we probably don't need all that technical mumbo jumbo in there and all the wiring up. So let's simplify this. Sometimes good times. No. Do we want this back? Maybe, maybe not. But we were happy with that. But then what came next is we had to bring in more speed. The early internet was kind of lightweight, but nobody really worried too much about speed because we weren't really doing anything too clever. But as we got more and more advanced, pages became heavier, servers had to do more. Google introduced their page speed checker, and suddenly we needed to have things quick because we wanted to be at the top of search engines, because everyone realized the only way anyone found you was a search engine. So what did we do back then? We just put caching in, as much caching as you could possibly put in. Just get the data forward from the database if possible, or put in a static caching mechanism in front, maybe using some sort of reverse proxy. Anyway, just keep it cached, keep that speed up. And that was it done. That was it. That was the easy days of the web. That's all we had to do. Just create some HTML, put a cache in front of it, walk away. It was great. But then somebody invented these small client libraries called jQuery. JavaScript was picking up, but JavaScript in the early days was a bit of a pain. Different browsers had different implementations of JavaScript. Netscape did not implement the same standard as IE. It was a pain. Then along came a great tool like jQuery, which abstracted all that difference away from us and gave us a really nice way of querying the DOM and doing lots of clever things in DOM. That meant that we can now create richer client-side applications. So now we could bring some more power into the user's browsers, especially since browsers were getting more powerful, people's computers were getting more powerful. They could actually do more on the client side as well. What this led to, though, was the shove it all in. We started to have tons of packages, every lots of little libraries being pushed into there to save us a bit of time, huge bulky downloads. Back then we didn't, we had minification and bundling, but we didn't have things like tree shaking or anything like that. So, you could have a JavaScript explosion when somebody just came to your website. It was fun, but it was a bit of a nightmare to manage. So that's kind of where we got to. And then we had the new challenges. Then we come more into more modern era where we start to talk about SPAs and SSG and things like that. And we'll go through those in a minute. So this brought in new challenges because, first off, we're trying to get rid. The idea is we're trying to get rid of the ASP.NET MVC. Microsoft have already kind of deprecated the old one. There is ASP.NET MVC core, but most people are thinking about how can we go away from more of these server-side technologies and put more into the client. This has led to these range of different options, which we'll go through. But you can see they're like the multi-page applications, which is your sort of traditional Sitecore project where you click a link, it makes a request to the server, loads you a new page, click another link, loads a new page, kind of moving away from that. So we saw the rise of the single page apps. React was really big at this. Angular and Vue were really huge on this as well. But people noticed that they had some challenges, especially with SEO being one of them. Again, the size of the payload being downloaded to a device was big. So well, how can we solve some of these? We have things like server-side renderings, partial hydration. But these are all the terms I want to introduce you throughout this talk, because when I came to this, I'm like, there is so much more now. It's not just HTML, CSS, and a bit of JavaScript. It's now a whole new raft of tools. So we'll start with static site generators. SSGs generally come in like two forms. Well, two good ones here. I've got Hugo and Jekyll. The nice thing about static site generators is that you build the site on your server, or probably part of a build process. You deploy those files to a server, and that's it. It's static HTML, super quick, nothing clever. You could put some JavaScript in here if you wanted to on the front end, but on the back end, there's no real work being handled. These kind of things are great if you just want like a really simple blogging site, or something like GitHub Pages, where it's just flat content. There's no real business logic that needs to happen. Documentation sites, that sort of thing. Really good. So if you have a really low requirement, you could definitely get on the static site generator. And the important thing to note with all these tools as well is they are tools that you can use with your Sitecore implementation. So you can do an SSG with Sitecore if you wanted to. Just using some of the API endpoints that Sitecore gives you, you could pull the data out as part of your build process, put it into your SSG, put the pages up somewhere, and done. Then you wouldn't need a CD server or anything like that. You just have these flat pages living somewhere, just being served up. Could be quite a good way of doing it. But then we come on to sort of the bigger boys, the sparse single page applications. So the idea with a single page application is you would hit a web server and you would download basically the entire application or most of the application at that point. And all the routing between pages when you change was actually really done on the client side. Through some clever JavaScript, you're not actually requesting another page when you change the page. It's actually just the client side code changing what you're looking at. So some JavaScript will run, the DOM will change. The application itself might go and make additional requests to get data from a server, so probably some JSON data to actually populate the next part of the application. But the idea being that once you've got the app on your client, why spend so much time going back to server and getting more HTML and more content? Let's make it really quick by just having data passed to us. And as you'll probably see in a lot of React Vue applications, like they are very quick because they're just on the client. But if you look at the payload sizes, you may be shocked by how much data is being downloaded, especially if you've got mobile users. The good side, though, is that they give very rich experiences. You know, if you want a full application experience within a browser, these are the tools that you're going to want to be using, because they make building like a proper application in the browser easy. You know, possibly not very good tools if you're doing a DXP solution where it's a brochureware or marketing or e-commerce site, because they're quite heavy and they don't tend to support SEO. But if you're doing an application where you need it to be feeling like a mobile app, these tools are great for that. To help with some of the challenges of SSG, with SPAs, we sort of see the next generation of client-side tooling, which actually tried to span both the server and the client, called server-side renderings. So Next.js is the sort of step forward from React. And it's probably the one you will hear quite a lot about. It's certainly the one that sort of penetrated most of the market at the moment in terms of SSR. And it gives you this ability to create a React app and then render the page, pre-render the page on a server, send that page to the browser, and then have it instantly appear, and then load a React app afterwards. And that process is called hydration, and I'll go more into hydration in a few slides. But what this does is it overcomes some of the challenges we saw when we were using spas, which is that first page load experience that a user might have. We've probably all heard of that fun stat, which is a user will probably stay on your site for about 2 seconds, and if nothing happens, they'll disappear. You know, people have a very small attention span, and so making sure that something renders on screen, captures the user's attention quickly is really important. And this is where things like Next.js come in, because they instantly load. The user starts to see something, and then the application comes in afterwards. Blazor is another great example of this as well, from the C# community. I don't know how many people have played with it, but it's really interesting to see now that Microsoft are bringing in this tool to span both the back end and the front end tools, which I really like as well, because it's written in C#. It means that we C# developers can now call ourselves full stack developers. The JavaScript kiddies have lost that badge. We now have it. So after this call, you can all go and update your LinkedIn profiles. Just put full stack on there. It's fine now. It's perfectly legitimate. So as I said, those are the sort of the technologies that are out there, sort of different types of rendering models that we have. And so now we'll sort of talk more about specific terms. So I already mentioned hydration, and hydration plays a big part in your development of these applications. And it's something most developers who've just worked on server-side rendering won't have come across. So if you're happy with your Razor renderings, you would have never have to have considered what hydration is. So what will happen in a a tool like Next.js is they will render a static form of the page on the server. What they will then do is send that static form of the page down to the client with a load of JavaScript. And when the page first renders, you'll see this HTML render and the page will just come up as a static page. So it will look like it's rendered and the content will be there, but it will just be the static HTML. It won't be the React application that sits in the background. What then happens is there's a hydration process where hidden data is sent with the request that allows the React application to populate itself with the data from the server and actually create the JavaScript application that's in the user's client browser. Once that application has hydrated itself, it is then interactive. So the important thing to note is that this render HTML section, that's when the page is visible. And it's this application interactivity is when the page is usable. And what you'll see is there's this gap between the two, which we call the uncanny valley. Okay. What we mean by this is that the page will be visible to the user and the user may start trying to click around and do things. But because the JavaScript application hasn't hydrated itself and isn't doing anything, the page may be unresponsive. And so for your user, they will be clicking and be like, well, why is this button not working? And they have to wait a second or two, couple of seconds, click it again, and then suddenly it will work. This is just one thing you have to be aware of when working with these apps, that there is this lag between visibility and interactivity. Kind of similar that we may have seen if you're doing client-side stuff with traditional like jQuery and stuff like that. You know, we JavaScript fire on the first load, but I think the difference there is just the scale. For most of us probably doing jQuery back in the day, you were using jQuery to add little tricks and bits of interactivity there, and that would just load really quickly. With a React application, it can be quite huge. Like megabytes of JavaScript may need to run beforehand, and so that time to interactivity can be delayed. So hydration is the first kind of thing you want to be thinking about. The next way we can look at solving this problem is with what we call partial hydration. Partial hydration is a way of breaking up the hydration process to make it quicker. So we kind of create, it's always funny when you look at things like we create a solution to solve one problem, we always create another problem. So now we've got another solution. So, you know, we created SSR because we want to give more, we want to have the kind of interactive with client, but without delay of loading, that something that React does. And now SSR has given this problem that we have this interactivity delay. So now we'll create another tool. So partial hydration is a way of breaking down a page. So certain tools do this. They say, right, instead of trying to send all the data for the entire page to your browser, what I will do is I will load part of the page. And then once that's loaded, I will then move down the page and get the rest of the data as I need it. So this might be on scroll. So when things become visible, it might be on time delay, you know, like the first section is done, then I'll go and load the second section, then I'll go and load the third section. Again, all of this is in the aim of making sure that that time to first interactivity is kept as short as possible. Possibly not too much problem again on like if you're doing brochureware sites, but if you're doing interactive applications, you know, you want, you know, where you don't want to actually delay the user from interacting with your app, pretty important. Another way to tackle this is what we call island architecture. Island architecture takes a different approach entirely and seems to be kind of like the most popular way that people are going now. It uses server-side rendering to actually generate the whole page. And then what it does is it looks at your DOM tree and it says, well, what parts of your DOM are actually interactive? So as you can see here, we've got a search bar that is interactive, maybe a couple of buttons, maybe there's some sort of list thing in the corner. And it's like, right, only those bits the user actually has to be able to interact with. So what I can do is I can render the whole page as static and then just send the JavaScript that's required to run these sections. Now, quite how they work out that magic is beyond me. It's done in the build process. There are some very clever people working on this. I haven't looked into how it does it. But what it does mean is then you have, and it's why it's called island architecture, you have these islands of interactivity across the page. Makes it very quick. Tools that are doing this well are things like Next 13 has just come out with that, and you'll see it's got server-side rendering components. Astro Build is a big one in this space. People really ranting and raving about it as well. So you definitely want to be probably looking at designing your architecture now if you're going into the headless space with something like Next or Astro, really. And don't worry about sort of the more legacy ones. Go straight to an island architecture. Another way of tackling this problem, though, again with interactivity, is what we call resumability. And I've only found one framework that's working on this way at the moment, which is called Quick. What the Quick does different, though, to try and remove this uncanny valley, is it generates the pages on the server, and then at the point of it sort of partially runs the app and then saves the data at that point in time, generates the HTML and sends it to the client, and that HTML will then be static. But what's clever about it is inside of that, wherever there is a level of interactivity, when you click the button, it will then, or interact with the page, wherever they've marked the interaction up, it will then go and find the JavaScript to run that interactivity and then execute it. So what this means is that basically it's not going to send very much JavaScript down to your client at all. And then as you need it, it will go and find that JavaScript and execute it and request it from the server. Now, this makes that first page load super quick, because it's just not sending any data to you. And if one of your aims is maybe to keep the amount of JavaScript you're sending to your clients to a minimum, this may be the way to go. Some of the challenges I can see with coming this sort of solution, though, is it's the JavaScript fetching problem, because you'll end up making lots of little requests to your server, and depending on your latency time to that server, you may see some delays in page interactivity just because someone's clicked it, it's had to get to the server, wait to return. If there's a lot of network traffic, that could be a problem. Maybe it's better to have requested that JavaScript up front. The plus side, though, is that in this scenario, the JavaScript you should be requesting from the server should be relatively small, because you're only requesting a JavaScript for one particular interaction. You're not requesting the JavaScript for the entire application, which is great as well. Is if you're a user who's only using 2% of the tools on the website, you haven't downloaded 100% of the JavaScript to only use 2 things on the website. So it has that advantage. So once you've decided how you want to render content on the front end using one of these different tools, next thing you think about is like, how are we going to actually run some back-end logic? Now, there are always the options of like APIs being hosted on Azure Functions or Azure Web Apps. But we also have now what we call edge rendering or serverless functions. These are, again, some of the more popular ones. So we have Azure Functions, Lambda from AWS. We also have Next.js have serverless. And what you'll see is quite interesting. In some ways, I think it's quite funny is Vercel keep building more and more stuff into Next.js. And sometimes it slowly feels like they're actually just rebuilding the whole server infrastructure that we had already back into Next.js. So they've recently just put session management back into it, into serverless functions, because people realized they needed some session states. But yeah, you will need to think about where is your business logic going to be running, especially in a headless environment where you've probably got one server that is just building pages and serving pages, but isn't necessarily doing any back-end logic. Like we might see like form saving, probably won't be there. Any kind of user data interaction, order processing, all that sort of stuff. Probably not going to be building it into the same server that is actually running and delivering your website. Cool. So I wanted to go through some tips now, my experiences of working in this environment, mostly relevant from Next.js. So you'll see a lot of Next.js stuff. I think it's worthwhile because, again, Next.js is probably the one that you will come across most or first to try. It's easiest to start with. So one of the tools I would really recommend is that all of these frameworks really try and push you towards a componentized page model. Okay, so breaking down each part of your page into an individual isolated component that knows how to render itself. And that component may be made up of other components. And this is kind of something we didn't really, well, the projects I worked on, I should say, didn't really take too much consideration of when we were working back in the sort of MVC Razor days, because we would tend to model our views around the controller action that we were doing rather than around the components that were within that controller action. Storybook is a tool that allows us, though, to see things as components and play and interact with them. And it's a really nice tool, especially working with clients, where you can create all your components. If you're using like atomic design habits and things like that, you can break your components down into atoms, molecules, organisms, all that sort of thing, see them bring together, play around with them, put data in. Like, you know, we've all probably been there where we've had a component where the title works beautifully if it's 15 characters long, but as soon as somebody puts 50 characters in, it wraps onto 2 lines and the whole design breaks. Storybook is a tool that allows you to play with that stuff beforehand. You know, you can go in there, you can put in a 500 character title and see what it would look like. So it's a really great tool for just seeing how your components look visually. What also is really good about Storybook is it forces you to separate your UI concern from your business logic concern. Yeah, because it's only focused on how does this component render, which means you can't really put any business logic into those components. What you'll want to do is have another component that pulls your UI components in that does the business logic. So yeah, so it's a really great tool. If you haven't had a chance to download it, download it. Next one, another tip here, hydration payload, the hidden payload. I mentioned web forms at the start of this talk, and hydration frameworks tend to have what we call the view state. The view state is essentially come back. So if you remember view state from web forms, the reason we had view state from web forms is because essentially the server had to perform a level of hydration when the request came back to it. So it'd send down its current page state, you'd send the request back with the view state. The view state would then recreate the page before the user did anything, then apply any user interactions over the top of it, and you would then have your events fire as necessary. This is kind of a similar thing, but it's kind of the reverse. Now we need the client to know what the initial state was. So the reason we had this hidden payload is because this is the thing that tends to this is the data that feeds the actual React application or the JavaScript framework that you're using on top of this. So the way these pages work is they will have the rendered HTML at the top, which is the thing that you instantly see when the page loads. And then at the bottom, they will have this hidden, huge JSON object hidden at the bottom, which is all the data that it took to create the HTML page at the top. The JavaScript application will run, it will read this massive JSON blob, and then create the JavaScript application on the top. And then at some point, it will swap out the HTML version of the page for the JavaScript version of the page. Now, the user won't see that swap because in theory, they should both render the same. But you can see that the payload for hydration can be huge. And also it can be a challenge because you have to be careful what is in the data you share with your components to not accidentally leak data, because it's very easy for a developer to output all the data that you think you need, plus some other hidden fields that you didn't render in your HTML, and you're like, oh, well, I didn't render those HTML fields, so I don't need to worry about them. Those fields in the HTML, I don't need to worry about them. But actually, those fields may actually be put in the payload itself. So you need to think about, right, this is where you need to start thinking about your DTOs and things like that. Like, what data am I actually maybe potentially outputting without knowing about it through using one of these frameworks? Hopefully that made it clear. I wasn't probably too clear on that, but if anyone has any questions about what I mean by that, please just reach out to me afterwards. The next challenge we have, and we hit this quite a few times, is what we call page build isolation. Tools like Vercel, I think Netlify is the same. What they will do is they will say, right, generate me a page. So we'll say page 1, and you go through and you know, it builds it, it requests data from the product database, in some content management system, some other system over there. And we all know that when we build a lot of these pages, you know, we've got the page header and the page footer are probably going to be the same on every page, and it's just the stuff in the middle that's really the kind of changing part of it. The problem with these systems is that they have no way of remembering that. So they build one page, and then you went to go, well, I want to build page 2, and it goes, well, I have no idea now what happened on page 1, so you've got to go through and do it all again. Okay, so then we have to go back and make all the requests again to the CMS to get all the information for the page header and the page footer, get the products again, go and connect to the other system that we connected to for data. So this creates a challenge because, one, we have to think about API request limits. You know, the SaaS infrastructure and the SaaS environment is all based around consumption models these days. So how many times did you request data? How many times did you make the CPU have to run? How many times did it have to connect to a data store? All that sort of stuff gets counted into it. And if you are building large sites using tools like SSR tools or SSG tools, you may find that you exceed some of these limits, or that your costs suddenly spike up because, you know, now you're having to generate suddenly 10,000 pages on the fly, so those sort of problems. So, you know, this is quite a big problem for us. So what we ended up doing is actually having to look at solutions that allow us to put caches, and caches always save you for some reason. There's always a cache that saves you. A cache between some of our data stores and the build process, to reduce the number of requests. So we would look at cheaper solutions like Elastic, which are very cheap to run. They don't really worry about how many requests you make to an Elastic instance. It's not really going to cost you anything more. So we could stick that Elastic instance in front of our data store and then just request data from it rather than the end system. Of course, doing something like that is great, but then we hit the second problem of caching, which is cache invalidation, the second hardest thing to ever solve in programming. So we solve one problem, but we create another problem. So that's always a challenge. Another big challenge for .NET developers and Sitecore developers is going to probably be the no session problem. We don't have session state to share between users. It means we have to have a different architectural model. This kind of makes sense in some ways because a lot of these things are about pushing more interactivity to the client side app. So you're going to be managing user sessions in the client app. But the problem with that, though, is we have different security considerations when we're in the client side. What data do we actually want to push to a client to store in that session? You know, what could be sensitive? What do we not want to be leaked accidentally because someone's just inspecting the memory on their local system? That sort of stuff. So not having a server-side session creates a lot of different challenges for us. On the plus side, we don't actually need to actually put a session server in the middle, so that challenge has gone away, but we create new ones. And then also limited business logic. You know, you're building a static page that's gonna be served to all users. You don't want to put too much business logic. You have to have like the most generic business logic at that point, and then handle either your business logic for specific users in the client side code or in an API somewhere else. And we'll look at that in a second. Cool. So that nicely leads me on to what I was saying, APIs and logic. Now, with these build systems, they are designed most of them are designed just to generate the HTML page and the basic JavaScript app. The actual business logic of your application needs to either be stored in the front of your application or in edge functions, or an app service or web service somewhere else, some sort of API endpoint. Again, as this becomes a challenge for developers, because now rather than thinking about our UI logic and our app and our business logic in kind of one single unit, which we might be able to do with like an MVC, we can think right, I need to do an order, so I'll do the order in the MVC controller, and then I need to render this. Well, I'll just output the whole model and then do the rendering in the Razor view and send that back. In this world, we can't do that. We have two distinct worlds we need to think about. We need to think about the UI logic for rendering any data, and then the business logic being somewhere else. And that business logic does its stuff, it sends some data back to me, and then I do my UI logic and updates separately. It's a more separated process. But it means that your APIs also need to be much more strict about their contract, the type of data they expose. Again, what data is going to be exposed on the wire, just because you're not rendering the data. If you send the data out through your API endpoint, then it's exposed in some way. You need to make sure that your APIs don't do accidental exposure. So make sure you've got good data transfer object definitions done. You're not just taking data from the database and just serializing it and putting it straight out, because that's the easiest way to accidentally expose data. You want to have some sort of mapping layer in the middle that maps to an external contract. You also think about how you're going to manage authentication, because you no longer can rely on your sort of forms authentication and cookies that you might have had before. It's probably going to be moving more towards a sort of JWT kind of, or OpenID kind of authentication mechanism, where you're showing authentication tokens, again, because the client is doing a lot more work, but you can't always trust the client. So these things become more challenging to think about, but also for me, I think it's a bit more of an interesting environment to think through. You know, feels like we're building a bit more. It's quite cool. So yeah, whatever route you do take, documentation becomes clear and it needs to become better. And I think we've probably done it before in the world before. So using things like Swagger documentation becomes really useful, because it then means you can have a team that are working on writing the APIs. The front-end team then can just look at that documentation and build from that, rather than having to have an understanding. So your back-end API logic becomes more black box to your front-end people, and vice versa. You know, the UI becomes more black box to your back-end teams. So communication and the contracts between them become a very important way of communicating. And that's all to say is that in this new environment, we have to think about architecting beyond Sitecore. So whereas before we could just think about Sitecore data, it's on MVC, which is in Sitecore, it's got Razor views, and I've got, you know, I got my helper functions to make it work with a page editor and stuff like that. Now we actually have to think far beyond that. We have to think about, like, right, our Sitecore instance is now just one part of a much larger ecosystem. We've probably got a Sitecore instance somewhere. We've got a build service that's generating static pages for us. Then we've got a UI that's got a rich client interactivity that's probably making API requests to an Azure instance somewhere, running functions, which is then using an Elastic cache to get data that may be also reverse proxying off to a CM, it could be Sitecore itself or to some other tool in the background. You know, that ecosystem becomes a lot bigger and a lot more complicated to think about. But it allows us to think in different ways and brings up new advantages in different ways to think about data. For example, you know, standardized API frameworks that you can use across multiple apps might be one thing that comes out of it. But yeah, but think architecturally beyond Sitecore. You're going to have to look at other tooling, other. So in conclusion, we have gone from the old world of everything being on a single Sitecore box and just serving out web pages to a much more complicated environment of different instances doing lots of different things, you know, breaking our Sitecore instances down into much granular roles, which feed then these different technologies to generate our websites. It's a lot more granular, it uses a lot more skills, but it is also kind of a more interesting and enjoyable space to work in, I would say. Having said that, but wait 1 second. This is kind of, I added these three slides in because of some things I found last week. So I haven't had a chance to play this, but there's this new old kid on the block called HTMX. It's kind of been around for like 4 or 5 years, but hasn't got a lot of traction. Oh, it hadn't been getting a lot of traction, but it seems to be coming out now and getting a bit more traction. What is interesting about HTMX is it brings back brings the ability to have an interactive page, React-like experience, without all the overhead of these JavaScript frameworks. Now, what that means is rather than you having to write a full React application or Vue application or anything like that, what HTMX does is it uses a declarative syntax on your HTML to say, as you can see in this example here, when this button is clicked, post a request to an endpoint and then swap the outer HTML out. Now, where this is different, obviously, to other JavaScript frameworks is that normally we think about, we've got an API endpoint and we're going to be communicating using JSON. And we're going to make a request, get that JSON payload, process that payload, and then render some HTML in the client side. What this does instead is it goes to the server with the request and expects the server to return HTML. It may be only a snippet of HTML. It's not expecting a full page, just a snippet of HTML. And what it will do then is it will swap the HTML in the current DOM with the HTML it just received from the server. So although that might seem like like it's like, oh, didn't we do that back in the day with jQuery? Well, we kind of did, but this is kind of bringing that back with a very nice syntax, with a lightweight. It's like 14 kilobytes to actually run. But what's also nice about this as a technology is because we're now just communicating with HTML over the wire, rather than JSON objects and JavaScript and all these new frameworks, is that we can get back to MVC if we wanted to. No, I'm not. I'm not saying you want to, and some of the cool kids will be like, "What? This is sacrilege." You know, we're like, we got away from this. But what it does mean is we could actually go back to just rendering HTML snippets on a server to do that interactivity. So you can imagine, you know, if I add a product to my cart, I click the button, I send this request off to the server to add the order to my cart. It sends back some HTML that has the updated cart view, and I just swap that HTML into my view. I haven't had to do any of the client side rendering of that sort of or any of that additional tooling. It also means that if I have a team like a lot of Sitecore teams, you know, we're bringing people who've predominantly worked on AS.NET MVC environments, Razor views, that sort of stuff. They have all those skills. If we move to something like the React ecosystem or Vue ecosystem or something like that, there is a lot of learning that these people have to do if they are to migrate into that environment. You know, and I've been through that learning. But it takes a long time. It's a lot of reading. It's a lot of evenings, you know, and not everyone has the time or the desire to do that. The nice thing about HTMX is it allows us to bring a level of interactivity into our pages without that team retraining. And I think that's one of the things that has to be really considered when you're thinking about going into these kind of new environments. It's like, it's not just about the technology tools, it's also about the team you're working with. And do you have the ability to upskill your entire team to this new environment? A tool like HTMX doesn't require you to do that. You know, you could get around it. And it's amazing to see, you know, there's quite a lot of chatter now about people moving away from these other frameworks and looking at this and going, yeah, this actually works. Because one of the important things is that we're not all building Facebook. You know, we don't often need that level of interactivity that something like Facebook, Instagram, or Twitter has. If you're building DXP sites that are like brochureware sites or e-commerce sites, simple e-commerce sites, that sort of thing, having a full React application running in a client browser to do a brochure website that sells a few products, it maybe just feels like overkill. You know, you're going to need, again, you need your Sitecore team, you're probably going to need some React devs, you've got a communications issue between the two, you know, all adds to the overhead of project delivery. So something like HTMX may solve a whole bunch of those problems where you can bring in that little bit of interactivity, make the page feel faster, but without having to upskill your whole team. You know, you can even put CDN caches in between because it's just HTML, and you're like, right, we just cache this, put some cache headers on, could be super quick. So I haven't done this myself, but I wanted to add it in because I think it's a really interesting way to think about a different approach to it. You know, the idea that actually going to full headless and composable may not be necessary. Maybe we can actually go back to maybe a bit more server-side stuff and just have better front-end tooling that helps us work with our server-side renderings in a different way. Cool. So finally, yeah, change is inevitable, growth is optional. I quite like this because you know, technology is always changing, and unfortunately we can't. Well, you can try and stay with the with where you were, but you will be working on some horrendous legacy systems. So always grow, always learn. Cool. Thank you. Any questions? I've either scared everyone.
I'll dive in here while people are typing if you want. The points you made around the security of data and the hydration process are quite interesting. Is that somewhere where people have looked at kind of tooling or automation to spot places where people are getting things wrong? Or is this really a developers have to think about it problem?
I think it's developers have to think about it problem primarily. And it's the same problem you have with APIs. And it's essentially is sort of the same problem, because what I've seen quite often with APIs is there'll be a model that represents the data in the database, and they'll grab that data from the database, and then they're like, right, I need to push it out on a JSON API endpoint. So what I'll do is I'll just serialize that model and send it out, without considering, well, what fields are on that model that you shouldn't be sending out, and what fields may be added to that model in the future that you shouldn't be sending out. So you have the same problem. It's like you always need to put like a DTO when you're sharing data across the internet that sits in front, so that explicitly states the contract and the data that will be exposed. And you have the same problem with the hydration, because it's very easy when you're on the server side to, again, grab loads of data from all these different systems, just create a JavaScript object that gets passed as what they call props into the different components, but not realize that actually on there was one property that was like the super secret field from the database. Now, you've not rendered that super secret field in your HTML because it was a super secret field. But the problem is that these tools tend to just serialize all the data that was in the props into that hydration. And so again, once it's hydrated, you won't see it. But if somebody looks at the view source, they will see your super secret field in that view source. So you have to have very strict contracts between the data you're getting from the server and the data you're passing then into the components for rendering.
Okay, thanks, Mike. Great, Jeremy, great question. So thanks, Michael, for the great presentation, and thanks, Jeremy, for the great presentation too. So we really had two informative sessions today, and thanks both of you from all of us, and thanks everybody for joining in. And like if you have any query, then you can directly post us or Jeremy or Mike, because we already have their social handle, so you can directly talk to them as well. So whatever way you want to choose, you can contact us on it.
Yes, thank you everyone for coming along, and thank you for having us.
Yes, thank you all.
Great to talk to them.
Thanks a lot.
Thank you.
Bye.
Bye-bye.